Welcome back everyone. This is a continuation to our previous video on linked list insertion, under which we have seen insertion at the beginning, insertion at the end, and now this video shows insertion at a random position. And here we assume that for inserting at random position, that random position is not at the beginning. So the position that we want to insert is not 1, because in this particular video we are assuming that the first node is at position 1, second node is at position 2, and so on. So for this particular video we are assuming that we are not going to insert our node at position 1. With that assumption, let us assume that we are given a particular position where we want to add a new node or insert a new node, and let us assume and based on that assumption we need to make another assumption to insert an element at some position p. To insert an element in the linked list at some position p, after inserting the element, the position of this new node is p. So the meaning of this could be something like this: assuming the first node is at position 1, second node is at position 2, third node is at position 3, and fourth node is at position 4. Okay, and we are assuming that we want to insert this particular new node at position 3. Okay, so after insertion is complete, then the node that we have just inserted will be at position 3. That is the meaning of this statement. So based on this assumption we move forward. So this becomes at position 4 and this becomes at position 5. Okay, so based on this assumption we move forward. If we want to add an element at position 3, now we are going to see how to design our algorithm. So if we want to add an element at position 3, let us say I want to insert an element at position 3. Okay, this is the position where I want to insert my new node. Then we stop at position 2. That means we traverse 2 nodes and insert the new node after that. Okay, so if I want to insert a new node at position 3, I have to traverse 2 nodes and then stop and insert my new node after that. So for simplicity, let us assume that the second node, that means the node where we are stopping, let us call it position node. Okay, let us call this second node as position node. So based on that naming, we will move forward to the 2 steps that are required to insert a new node at a particular position in a linked list. So the first step tells us that new node points to the next node of the position where we want to add this node. So basically we have to make this new node point to the next node of the position where we want to add this node. So as I already told you, we have to traverse 2 nodes for inserting at 3. So once we have traversed the 2 nodes, we have to find out this next, which is pointing to the next node, and make this node point to the node which is currently pointed by this next of the position node. Okay, then that was the first step. Okay, the second step is to make this position nodes next, as it is mentioned here, position nodes next pointer now points to the new node. So we have to take this position nodes next pointer and make it point to new node. That was one way of doing it. There is another way of doing it. Okay, so let us say I will maintain two pointers. Okay, we will see it in the next slide because it is already mentioned in the next slide. Okay, let us do it the other way. This is, we can say, second way of doing it. Second way of doing it. Okay, so here we are having a position, that is where we want to insert. Sorry for this. This should be 3. This was designed for a separate algorithm. Okay, so if we are inserting at position 3, that means if we are inserting here, okay, then we must traverse 2 nodes, right? That part is common in the previous algorithm as well as this algorithm. Here we will maintain 2 pointers. Let us say, I will say this will be pointed by a pointer called current. Okay, and I will maintain a variable called count. I will maintain a variable called count, and initially count will be 0. As soon as I move from one node to another, count will be incremented. It is very much like traversal that we have seen in the first video. So I will make current pointer point to the first node, and once I am at the first node, I make count, because sorry for this, count is 1 here. Okay, because our first position is 1, we are making the count as 1. If your first position is 0, you can make your count as 0. Okay, so if the current is pointing to the first node, and if count currently is 1, we check a condition. We check whether count is less than position. That is the basic condition that we have to perform. Why? Because as I told you in the previous slide, that we have to traverse the one less number of nodes based on the position we want to insert. If we are inserting an element at 3, we have to traverse 2 nodes. If I am inserting an element at 2, I have to traverse 1 node. If I am inserting at, let us say, at position 4, I have to traverse 3 nodes. So I am checking as long as count is less than position. That means as long as I have reached just before the pointer. I mean, as long as I am below this 3, I have to keep moving this current to the next node. That is what we have done in traversal, somewhat similar to traversal. So here, first count is 1. So 1 is less than position. As we can see, it is 3. 1 less than 3 is satisfied. Because this is satisfied, we make this current stop pointing to the first position, but make it point to the second position. Okay, as soon as we make, even before doing this step, that is, even before making this current pointer point to the next step, we have to make sure that we make this previous node point to another pointer called previous. That way we maintain 2 nodes at the same time. One will be the current node, which will be moving forward, and there will be another pointer which will be keeping track of the just before node. So once we are at here, we make the count variable increment, so it will become 2, and once count becomes 2, again here we check whether count is less than position. 2 is less than position is satisfied. So again, even before making this current moving to the next node or next element, we have to make sure that currently previous is pointing here. Okay, and then once you have made this previous point to the current element, we have to disconnect this and make current point to the next element. Okay, once we have reached here, again count will be incremented. Count becomes 3, and when count becomes 3, again we perform this condition check where we check whether count is less than position. So this is where it fails because we have already traversed 2 nodes for our third position. So when 3 less than 3 is not satisfied, it has to quit. So this is where we stop. And this is the second step. As you can see, currently the second node is pointed by previous, the third node is pointed by current, and this is, as I told you, this is another way of achieving the same algorithm. So here what we will do is we will take the next of new node and make it point to current. This is easier way of saying next of new node pointing to the next of previous or whatever, or position node, as we have seen in the previous slide. Okay, and once this step is over where we are pointing this next of new node to current, then the second step is to make the next of previous point to new node, and this is exactly what we are going to see as a program in the next slide. So here this part is pretty much common that we have seen in the previous 2 videos. We are we are basically creating a memory and allocating it to the new node. Okay, after that we are making the current point to start. Then as long as current is not equal to null, it basically checks as long as it has not reached the last element of the list. Then here is what is the main condition that checks whether count is less than position, which tells us that we have to traverse one less number of nodes based on the position. So in our case, because position is 3, we have to traverse up to count is equal to 2. So this will continue from count equal to 0 to count equal to 2 for 2 times. So we are making the previous point to current and then current to point to the next element of current. So basically current will move to the next element and previous will point the current element, and count is incremented and so on. That is what happens here. And once this while loop is complete, our current is pointing to the third element and previous is pointing to the second element. And then once that is over, we are taking the value that is being passed to the function and then assigning it to the data, and then that is the negligible part which we will see in the next slide. Here these 2 steps are very important where we are making this connections, these 2 connections. So here we are saying the next of new node to point to current, that is what we are saying, next of new node point to current, and then next of previous point to new node. So next of previous point to new node, and this is a step-by-step evaluation of step-by-step analysis of developing a code out of the analysis of this, how to insert a particular node at a particular position in a linked list. So this is the complete code. This is just an assimilation of what you have seen previously. Here we are, this is the only difference that you can observe compared to the previous 2 functions where we had insert at beginning and insert at end. We had only one parameter in the parenthesis of this particular those 2 functions, but here we are having 2 parameters. One is a value and then another one is a position. So if you want to make a call to this particular function, you will be saying it as insert, I'm just writing it short, insert at position, let us say. I'm just writing it short, as I told you. It is very hard to type write with mouse. Okay, so if I say I want to insert 4 at position 2, okay, this is a function call. If I write like this, then this 4 will be passed to this variable value and 2 will be passed to this variable position. So here it will be 2 and here it will be 4 once I make this function call. So here as you can see, in the place of position, value 2 will be used. So if position is 2, this loop will continue as long as count is equal to 1. Sorry, count from 1, so it basically it will traverse only one node if you want to insert at 2. Okay, and then this value 4 will be used here to assign the value to the data of our new node. And this is the overall code for your insert at position, and this is your program for insert at position. And we are assuming that, as I told you in the starting of the video, that we are assuming that we are not going to insert at position 1. So try checking this, try making different calls with different values for value and different different numbers for value and different numbers for position, and check what are the different cases where it works. Try to give 1 as the position, try to give 2 as the position, try to give 3 as the position, try to give some number which is more than the list size, and try to see whether it works. That's it. Thank you.